Hello, on November the 3rd. Technically, I'm still working. I'm running an end-to-end test and repeat it 10 times. Each one will take about 5 minutes, so it'll take about an hour to finish. So I'll just let it run. That test just been, how should I put it? Just so bad. I've been just dealing with this for the past few days and just trying to fix it, but it's it has a lot of moving parts, and then it's not an easy thing to do. But anyway, let's do this. Find x sum of all k long subarrays. We have nums of n integers and 2 integers k and x. The x sum of the array is calculated as the following. Count the occurrence of all elements in the array. Keep only the occurrences of the top x. Keep only the occurrences of the top x most frequent elements. If two elements have the same number of occurrences, the element with the bigger value is considered more frequent. Calculate the sum of the resulting array. The sum of the resulting array. Note that if an array has less than x distinct elements, so it has to be distinct, its x sum is the sum of the array. Return the integer array answer of length n minus k plus 1, where, what is k? Answer I is the x sum of the subarray I to I plus k minus 1. Oh, so 0 to 5, right? 0, 1, 2, 3, 4, 5. So this is the first. So we want is the top x most frequent. So I have 2 1, 2 2, 1 3, 1 4. So I pick 4. So it could be 1 2 4. That is not right because x equal to 2. I only take the top 2. Oh, top 2. Madre mia, top 2. Wait, 1 2, and then we do this. All right. Top 2 is gonna be 2 2 2 and 4. Correct. And then we do this. It's gonna be 2 2 2 and 3. 2 2 2 and 3 3. So 6 plus 6 is 12. Okay. So it's a sliding window. We can always get, but we need a top. How can you do top? I mean, we kind of have to sort every single time, but we want to sort based on, so we can do an ordered map, but can we order based on the value instead of, I'm not sure if that's even possible. Well, I can, let me think. Because every time we expand, we will remove some, we add some, right? So the state changes. I'll definitely have something to keep track of the count. And then I'll have another thing. Most likely it's a heap. But if it's a heap, then you pop. So every time you pop, you have to put it back in. So might as well just sort it, right? We can sort it. I might as well use a, ordered set. So ordered set. But what if we have something that doesn't belong? What would be the good data structure for this? It does feel like a heap, right? So a heap, you can decide how you want to order them, right? How you want to order them. So we'll say we order based on the value first, and then we based on the numbers second. So we do that, and then we just pop, right? We pop one, put into another heap, right? We put into another heap. So we go through the top, but we have to continue, put everybody into the other one, and then we replace it. Yeah, I guess it's okay. I guess it's fine. Okay, we'll try a heap then. So C++ is min heap. And this feels complicated. And also heap is hard to write, if I remember right. So if I can help it, I'd rather not write custom stuff. So I use a heap to extract the top x most frequent element. I don't know, so you have to go through, so on, and each time you have to go through k. No, each time you have to go through x, right? So it's going to be x log n. I think that's the time complexity. All right, so all we need is a priority queue, and we're going to use a pair of int and int. Okay, so it's a max heap. So the pair is going to be so we worry about the count, the frequency first, and then the number, right? And they say we want the large frequency early, but if they're the same, the little bit bigger one goes early. So this directly, we don't have to make any change. So we need a vector, right? Counter. We need a counter. We know the maximum is 50, so we do 51, and then we will go through k, right? So the answer shall have how many? Length of this. Okay, so we say n equal to num plus size, and then we say vector int res is going to be n minus k plus 1, right? And then we say for int I 0 is smaller than n I plus plus, right? Doesn't matter. Whenever we have some stuff, actually this is no good. This is no good. because we just cannot do it this way. We have to get the first x. Yeah, first x. We need to get the first k, right? First k. K is smaller than nums.length, so we get a first k. Yeah, it doesn't matter. We get a first k. We get a first k. We get a first k because I need to update counter, right? Nums I plus plus. We need to do that, and then once we do that, we need to put everybody into the queue, right? Into the queue. And then what? Then I get the first result, and then I will update. Okay, yeah, it's fine. 4. Right, I is smaller than if okay, so that's that. And what are we going to do? We are going to do a count and then move on to the next one. See, that is the issue. That is the issue. I want to combine the logics so I don't have to write it separately. How do I combine the logic? Well, you combine the logic by not go through k, right? So you start with k plus 1, I start with k minus 1, which means you add it, right? Once you add it, you will check, right? You will check if it can remove, and then the answer is you cannot remove because minus k is smaller than 0, right? Minus k is smaller than 0. So now you have it updated, and then you're gonna go through the top, right? You go through them one by one. If it's equal, then you get it. So you go through x of them. Okay, so basically I don't get to all of them. I do that, and then we say for int I equal to k. Okay, I smaller than ni plus plus. So first things first, counter nums I plus plus. This is the first thing. We add it, and then we say if and then pq.push, right, for sure. When I push counter, right? Hold a second. Push counter nums I and nums I. Okay, so this is a new thing. We push it in, and then we say if I minus k, right? Oh, actually, this is not k. My bad. K minus 1. That's right. I minus k. I minus k, if it's larger equal to 0, right? That means we shall remove it. So we will do counter nums I minus k minus minus, right? Minus minus. And then we say if counter nums I minus k is larger than 0, then we say pq.push counter nums I minus k nums I minus k. All right, this is basically just to update. Okay, so we update the counter. Now we're gonna go through x times. All right, we're gonna go through x times, and then to see what we have. All right, see what we have. So we just go while this is, so we say while, but we need a temp, right? Yeah, we need a temp. Okay, so here we say std priority queue pair int temp. Okay, we say while int x, okay, count equal to x. So while count is larger than 0 and pq.empty, pq is not empty. So the top we say const auto frequency num go to pq.top, right? pq.pop. If counter num is equal to frequency, right? If this is the same, then res. Do we have res? We don't have res. Oh, we have. My bad. We have res. So res I minus k plus 1 plus equal to num times frequency, right? Once we're done, x count minus minus because we used 1 already, and then we'll say temp dot oh, I don't need, I can just temp doesn't have to be, it can just be a vector. So we say temp dot pushback frequency and num. Right, so temp dot pushback, this is just temporary. I don't even need temp, just need to be temp just need to be int. I just do pushback number. I don't even need to do the other thing. Yeah, I just push back number. Okay, so we push back number, right? So temp dot clear. Okay, yeah, so we push back. So if it's equal, then we just do this, and then we keep doing this, we keep doing this, we keep doing this. Now if it's not equal, we skip, right? We skip. So only equal that we do this. So eventually one of them will get out, right? Get out. So once we get out, we can say is while, oh, I'm gonna pop this. So while temp dot empty, we say pq dot push temp dot back, counter temp dot back. Okay, temp dot pop back. So we put them back in, right? And then we move on to the next one. And then at the end we are gonna just return res. All right, let's take a look. This one is not right for the second, which is interesting. We do 2, right? So the first 2 should be 11. Why is 6? I don't understand. So k equal to 2, 2 minus 1. Yeah, so I can only do this. I'll be 1 and 3, right? 1 and 3. And then we have this because it's 2 minus 1 is 1, right? And then it's going to be 8. And then we'll push 1 and 8. And then 1 minus 2, so we don't do this. Column should be 2. Top frequency is 1 and 8. Yes. This is k minus 1, so this will be 0 plus equal to number 1 minus will be 8. How come we start with 6? Okay, yeah, we need to debug this. Yeah, because I don't know. I don't know why. What's the function name? Find xsum. Oh, hold on, we have other things. K equal to 2, x equal to 2. So k and x. I think I'll probably start from here. I can't believe it. This is an easy question. And I won't say struggling, but definitely need a little bit more effort. Okay. All right, let's see what you got here. All right, so we have as 1 counter. Oh, that's fine. We can't really see counter. So, okay, PQ. We have PQ. We should be able to see PQ. PQ we have 2. Okay, so 1813, that's correct. And then this will skip. So the count is 2. PQ not empty. And then we'll get frequency and top and then pop. Num frequency. Oh, it doesn't really tell me what it is, but it is. So should be 8, right? Three. I see why. So if I pop it, so I don't pop here. Huh, you don't pop here. Then where do you pop? I finish this, then I pop. I pop towards the end because it's taking a reference. This one is taking a reference. Okay, first one's right. And then we got issues. Yeah, it's okay. So this will get num pushed in. So it should get 3 and 8. Right? 3 and 8. And then PQ get popped. So I actually have no more PQ here. So yeah, it's not empty, so I'll push them back. And I'll pop back. Oh shoot. It's order is wrong. Frequency first. Okay, and so blah blah, 8 is right, 7 and 8. 7 and 8. What went wrong? Yeah, I will pop it because it's 8 is not right. Oof. Alright, let's check again. Let's check again. Alright, so beginning should be right. So rest is 8. Counter is 1. Temp shall push 8. It's good. Next, I'll pop it. Right, next 3. Temp push 3. We have 11. Pop, nothing. Get out. So I push them back. Right, push them back. 1, 3, 1, 8. Done. Next one, I equal to 2. Right, I equal to 2. 2 will add a 7 in it. Right, I add a 7 in it. 2 minus 2 is equal to 0, so 0 need a minus minus. So counter 0, and then it's larger than 0. I don't push. Because it's a 0, I don't push. Okay. Yeah, so 3 should be 0. So x is going to be 2, counter to 2. So frequency, we got 8 out first. Yeah. 8 out. Next is 7. Done. Coming out. 8 and 7. Push both back. 8, 7. And move on. Next one. Next shall be 8 again. 8 again. So we're pushing into this. Yes, so we actually remove 8. Right? Remove 8. Oh, I think we have duplicates. Huh. Darn. Oh. We have duplicates. Gosh. I don't know what would be the most efficient way to do this. Okay, I can do pair. We saw primary based on the first and then secondary based on the second. So I just read from right to left, right? But how do you delete? How do you delete? Order set delete element. Delete by value. Delete element. Delete by value. Delete order set with pair and delete element. Insert to delete, erase. Okay. Yeah, I guess it's fine. So you can erase and then push again. All right, so basically we're gonna change the data structure. So we'll use the order set. Okay, so we say use ordered set with pair, frequency, and number. All right, so we say a set. I think it's fine. So this is gonna be a frequency num set. Okay, we still need counter because counter will tell us which one to remove. Okay, we have this, we have this, we need to have this, we need to have this, but it's not push. It's gonna be frequency this dot insert. Right, insert. Okay, so we have a temp. We probably don't need temp because everybody in the set will be correct, right? Will be correct. So we'll do this, and then actually we need to. Yeah, we do this. We will say frequency this dot insert frequency num set dot erase. So we counter nums I -1 because it must be depends, right? We say if counter nums I -1 is larger than 0, that means it's inside, then we need to remove it. Right, so we say this -1 nums I, right, we remove it. And then if this, we'll do this, right? Well, minus, then we say if this is larger than 0, then we will add it. Right, we say frequency num set dot insert this, and say also if counter nums I minus k, plus 1. No, it's always going to be, the plus 1 is always going to be in there, so I can just remove it. Frequency num set dot erase counter nums I minus k, right, plus 1. Plus 1 nums I minus k. Right, so we erase the original one and then we put this if it's necessary. Okay, so this we update the frequency and then we do this. And we actually don't need to do this. We can go iterate from right to left. Let's say for auto it equal to frequency this dot back and reverse begin it smaller than frequency this dot reverse and count is larger than 0. I do need this one to be here. Then it plus plus. All right, and then we basically just say res. So it dot no, it's going to be I minus k plus 1 plus equal to it dot first multiplied by it second. And then count minus minus. Where is count? Maybe I need this. Invalid operands to binary. I think it's not equal to. So I do this. Count minus minus at a certain point, it will get out. Then we don't need any of this. And then we move on to the next one, and then we update. So we do on. Right, and each one insert will cost log n. Right, and this is also log n. O and log n. I think it's O and log n. Actually, it's going to be log n here plus x. Alright, let's try this one. I mean, you can always brute force this, but I try to make it a little bit more efficient. Yeah, a little bit more efficient. Okay, that's that. I mean, it's actually harder than I had expected. Much harder, I would say. Hash table and then sort. Yeah, you just sort every single time, which is fine. Yeah, you can always do that. So this, I do the count. You have to use a pair to the value and key. Then you have the sorted. Then you have to get a first k. Then you do this. And yeah. Anyway, that'll be it. I'll see you guys tomorrow.